Hey everyone, today we're going to differentiate these two functions. So, over the first one, we're going to apply the chain rule as well as the quotient rule. I think that's it. So let's see how that goes. So we are looking for the derivative function y prime. And so that's going to be using the quotient rule, the derivative of the numerator times the denominator. So that means the derivative of ln of 10x, meaning 1 over 10x times the derivative of 10x, and that's secant squared x, times that denominator, so times root of x squared plus 1, right? Minus, by the quotient rule, the numerator, so the ln of 10 of x, that's a bit funky, times the derivative of the denominator. Now, the derivative of the denominator, I'll remind you, the square root of x squared plus 1 is the same as x squared plus 1 to the 1/2. So we can differentiate that by the chain rule. And so that'll be times 1/2 x squared plus 1, drop the exponent by 1. So to the negative 1/2 times the derivative of x squared plus 1 by the chain rule, right? So times 2x. And all of that over our denominator squared, which is going to cancel out the square root and leave us with little old x squared plus 1. Okay, so there's step one. Now let's try to clean up that numerator, okay, because that looks pretty messy. So again, our derivative function y prime is going to be, we'll have now secant squared. 1 over 10x is cotan x, and cotan x is cos x over sine x. So let's think about that. That's cotan x, right? This reciprocal of tan x is cotan x. I'll even write that down over here. Cotan x is cos x over sine x. And then multiplying that is secant squared x, which is 1 over cos squared x. And so what we have here in this product is one of the cos is going to cancel. So we'll have 1 over sine times 1 over cos. And so we could write that as 1 over sine is cosecant x, and then the remaining 1 over cos is secant x times that square root of x squared plus 1 minus, now the 1/2 and the 2, you can see those will cancel. And so we could simplify this down to x ln of tan x. And since we have x squared plus 1 to the negative 1/2, that means that this term itself is over the square root of x squared plus 1, and the entire numerator is still all sharing that common denominator of x squared plus 1, right? And so let's move it along. So now we have, in the first term, we have a square root of x squared plus 1. In the second term, we have 1 over the square root of x squared plus 1. What I'm going to do is I'm going to multiply the top and bottom of the entire expression by the square root of x squared plus 1. So we're just multiplying by 1, so we're not breaking any laws here, right? So what's going to happen in the first term, the square root of x plus 1 times itself is going to be just x squared plus 1. So that means that our derivative function is going to be cosecant x times secant x times x squared plus 1, right? Minus, in the second term, the square roots of x squared plus 1 are going to cancel each other out. And so we'll only have minus x ln of tan x. And that will be all over this new denominator of x squared plus 1. I'll remind you, that's like x squared plus 1 to the 1 times x squared plus 1 to the 1/2 for the square root. And so when we multiply by the same base, we add exponents, right? Classic exponent laws. And so our denominator is therefore x squared plus 1 to the 3 over 2. And here is the cleanest expression I think we could have for y prime. So there we go. Now, for number 2, this is going to be less quotient rule, more chain rule. Okay, so let's see how this one goes. So again, we want the derivative of y, so let's use different notation. Let's say dy dx this time. Just mix it up. So we'll have The derivative of sine is cos, so we'll start with the cos of all of that, cos of ln of tan of ln x. How many brackets do I need? 3. Now, this is where the chain rule comes in, times the derivative of this stuff. So times the derivative of ln of tan of ln x. So that'll be 1 over times 1 over tan of ln x times the derivative of tan of ln x, right? So that'll be times secant squared of ln x, right? Derivative of tan is secant squared, so that'll be ln, okay, ln of this is going to be 1 over that times the derivative of that. And then the derivative is going to be, the derivative of this is going to be secant squared ln x times the derivative of ln x. And the derivative of ln x is 1 over x. There we have it. Yes, okay. So that means that we can write dy dx, our derivative function, is, again, we have a 1 over tan of ln x times secant squared of ln x. Now, I didn't plan for this to happen, but we actually already dealt with this in example 1. So that's convenient. We managed to simplify 1 over tan times secant squared to cosecant times secant. Now, let's just be mindful, it's of ln x this time, right, in both instances. And so let's keep that in mind. So what I'm going to do is we'll simplify this stuff to cosecant times secant, and we can finish this off with, I'll leave the over x by itself in the denominator. So I'll write my entire numerator all over that simple denominator of x. And so we'll have, this will be again cosecant times secant. So we'll have cosecant ln x times secant ln x times this ordeal times the cos of the ln of the tan of ln of x. And I think that's everything. That's there, and then that's there. And so we're done. And here is our cleanest expression for our derivative function dy dx. So chain rule, quotient rule, product rule, all that good stuff. Hope that helps, and thanks for watching.